start this session with a small story from the life of Messi. I think both of you know about Messi. So he's actually a great football player from Argentina. So this story is related to his earlier football career when he was a very little known footballer who was playing for a club in Argentina. So once his coach wanted to test how his disciples have learned the art of football, especially the art of taking the penalty kick. So he called all the team members, and then he just asked one of the senior most person to come and have a shot at the penalty. So when that senior player came and then started taking the aim, then again the coach asked him, "What are you seeing?" Then the senior player told that he is seeing the goalkeeper. Again, the coach asked him, "What else are you seeing?" Then again, the senior player, he wanted to impress the coach. Then he's told that I'm seeing the net behind, I'm seeing the empty stand behind, and I'm seeing um, uh, some other sea which was there behind the ground and all. So again, the coach again checked the quality of the football, what he was trying to kick, and whether his shoes and socks were made of good quality material. So he was not satisfied with the quality of the inputs and the process conditions. And then he asked the senior player to quit even without attempting. So like that, one by one, all the other players came and the coach was asking the similar questions and the players were giving the similar answers. And the coach asked them to quit one by one, even without making an attempt in the goal. So last came Messi, who was a favorite disciple of the coach. So again, the coach asked him, "What are you seeing?" Then Messi told that I am seeing the goalkeeper. Again, the coach asked him, like, what else are you seeing? Then Messi told that I am seeing the eyes of the goalkeeper. Again, the coach asked him, "What else are you seeing?" Again, the Messi told that I am seeing the legs of the goalkeeper. So again, the coach checked whether the football was made of the right quality material, whether his shoes and socks were made of good quality material. So whether he was taking care of the breeze that was passing through at that point of time while he was taking the aim. And then once he was satisfied that all the inputs and the process conditions of Messi were right, then he gave the approval for Messi to shoot the penalty. And then Messi took aim and then he shot the penalty. And again, the ball landed in one corner of the goal. So even though this story was happened a few tens of years of 50, some 10 or 15 years ago, and that too in a football field, this particular concept is applicable for everywhere in all processes. The concept, what we call as a process approach. So this process approach is one of the basic principle of Six Sigma. So before trying to understand what is process approach, let us now try to understand what is a process. So a process is a set of activities done to convert the inputs into outputs. So this definition is applicable for all processes, whether it is a natural process or whether it is a manufacturing process or a service related process or a software related process. So this definition is applicable. The process is a set of activities done to convert the inputs into outputs. So first, let us take the example of the digestion process. So for the digestion process, maybe the input is the food, whatever you are taking. So this food is taken through the various organs in your body, like the mouth, tongue, the teeth, the food pipe, the small intestine, the large intestine, stomach, kidney, and so on. and it is processed under various chemical and other acidic conditions. And then finally, the output, whatever you are getting, is the energy and the excreta. So the food is the input, and this input is processed under various process condition. And then finally, we get the output as the energy. Maybe on a particular day, you had some stomach indigestion problem. So you went to the doctor and then told him that you have the problem of stomach indigestion. Then the doctor will try to ask you, like, is this problem happening for the first time, or has this problem happened many times before, or when this problem has last happened? And then is there any pain in your stomach or intestine or any other place? And then did you have any outside food? So like that, he will try to ask many questions to you, trying to understand whether there is any problem in the inputs or the process condition. When he is asking so many questions, then maybe you may remember that 2 days back, you had some pizzas in a outside restaurant, and only from that day, this problem is of indigestion is there. Then the doctor will analyze that the problem of indigestion is because of the pizza you had in the outside restaurant, and then he will just recommend some medicines to take care of that problem. And then once you take these tablets, then your problem is going to be solved, right? So that similarly, in our process also, many times we have problem in the outputs. So we have a problem of lower productivity, lower yield, the bad quality of the material, inability to meet the on-time delivery of the customers. So a lot of problems we are facing, and we are under tremendous pressure from our senior management to solve all those problems related to the outputs. So again, in our effort to solve these problems in the outputs, then we just work day and night in order to really try to solve the problem, calling the people and then discussing with them what may be the possible reasons for the problem, and then taking some actions. But again, we find that the problem seems to be resolved for some time. But again, after a few weeks or few months, again, the same problem will come and again disturb you, because you have not identified the root cause of the problem. And because of that, the problem may be repeating. So the process approach says that in order to solve the problems related to the outputs, then you need to understand what are the problems in the inputs and process condition, right? So if you have the problem in the inputs and process condition, then definitely there will be a problem in the outputs. And in order to solve the problem, then you need to analyze what is the problem in the inputs and process condition and try to solve that. So this is what the coach was trying to do. With all the other disciples, he was found that either their inputs were not right or their process conditions were not right, and he was not sure whether they will be able to hit the goal. But with Messi, he found that all his inputs were right and all his process conditions were right. So he was 200% sure that the Messi will hit the target, and he gave the approval for Messi to shoot the penalty. And then the Messi was able to score the goal. So the process approach says you control the inputs, control the process conditions, then output will always be consistent. So I'm writing it for you. Maybe you can take your notes. The process approach says is a very important fundamental principles of Six Sigma. The process approach says that control the inputs, control the process conditions, the output will always be consistent. So whenever you have problem in the outputs, whenever you have problem in meeting your goals, then don't panic too much. Don't bother too much about the outputs. Try to analyze what are the problems in the inputs, what are the problems in the process conditions. Then try to take action on those inputs and process conditions. Then you will find that your output will always be consistent, right? So that's what we call as a process approach, which is one of the fundamental principles of Six Sigma. Okay. So if you want to learn about Six Sigma, the other important concept what you need to understand is about variation. So what is variation? Variation is simply a deviation from expectation. So I'll again give an example so that it will be easy for you to understand. So assume that you are now taking a 11 millimeter rod, and then you are just taking it to a grinding machine and grinding it to 10 millimeter rod. So your target is to get 10 millimeters, and maybe the customer is willing to accept from 10 plus or minus 0.5. That is from 9.5 to 10.5 millimeters. So whenever you start grinding the rods, then you are aiming to get 10 millimeters. But again, after running the machine for 1 hour, you have produced around 5,000 pieces. And you are now randomly picking up some 50 pieces, and then you are measuring the diameter. So do you think that you will get the exactly 10.00 as the output for all the samples, whatever you are measuring? Yes or no? Can you just tell me? Do you think that whenever I'm measuring the samples, then will I get exactly 10.00 or there'll be something different? That is also possible.
Something is different. You will
Yeah.
accept.
Yeah. So whenever I'm just, even though I'm targeting to get a value of 10, then all the samples, whatever I'm going to measure, is not going to measure exactly 10.00. So I may get some pieces like 9.85, some pieces at 10.15. So always there will be some variation. So this variation is simply a deviation from the expectation. Even though we have some target value, it is not possible for us to meet the target value 100% of the time. Always there will be something less, something more. So this variation is any process, variability is inevitable. So whether it is a natural process or a manufacturing process or a service related process or a software process, everywhere this variability is inevitable, right? For example, now you are making some plastic component, then the dimension is one of the very important criteria for the output. But again, the diameter may not be the same for all the items, whatever you're going to produce in a particular day. Same way in a service center company, maybe you are employing maybe more than 10,000 employees. Then the productivity levels of all the 10,000 people is not going to be the same. Always there is going to be some variation. So because of which that your inability, you will always find it difficult to meet the delivery requirements of the customer. Because sometimes people may do with a good productivity, sometimes their productivity may be low. Sometimes some people will be very highly productive and some people, their productivity level will always be lower. So this variability in any process is inevitable. So these variations in the output are caused by the variations in the inputs and the process condition. So as you have learned in the previous concept, any variations in the output are caused by the variations in the inputs and the process condition. So sometimes what happens is the variations in the inputs and process conditions are too high that the process starts producing some defective item. So for example, assume that now you are producing this rod and 10 millimeter rod, and the customer is giving a tolerance of 10 plus minus 0.5. So that means he's willing to accept from 9.5 to 10.5. So initially your process was producing from 9.3 mm, 9.7 mm to 10.3 mm. Then you find that all the rods were meeting the specifications of the customer. But suddenly what happens is maybe one of the bolt in the machine has broken. So because of that, the vibrations in the machine started increasing. And because of that, the variations in the output also has gone up. So now instead of producing from 9.7 to 10.3, now we are getting a more variation. So you are getting from 9.3 millimeter to 10.7 millimeters. Right? So 9.3 to 10.7 millimeter. So that means whatever you are producing from 9.3 to 9.5, that is going to be a rejection because it is less than the lower value, lower specification. And whatever you are producing above 10.5 and below 10.7, again, that is also going to be a rejection because of it is higher than the higher value. So now because of this increase in the variations in the input, then there is an increase in the variations in the output. And then because of which your process is producing defects that is not meeting the customer requirement. So the Six Sigma methodology helps you to reduce the defect by reducing the variations in the output, by reducing the variations in the inputs and process condition. So again, I will write it for you. The Six Sigma methodology helps you to reduce the defects. So how do you reduce the defects? By reducing the variations in the output. How do you reduce the variations in the output? By reducing the variations in inputs and process conditions. So whether you are producing the plastic components or steel pipes or whatever you are making, then always you are doing some grinding or you are doing the welding or you are doing some bending. So whatever the process you are doing, then you will have to ensure that the inputs and your process conditions are maintained within a very narrow range. If the variability in the inputs and process conditions are reduced, then accordingly, the variations in the output also will reduce. And accordingly, your defect rate will be very less. So the Six Sigma, if a process is running at a Six Sigma level, then the defects, whatever are going to be produced, is only 3.4 defects per million opportunities. For example, if you are making some plastic bottles, and on a particular one day, you are making some 1 million plastic bottles, so out of this only 3 bottles are going to be defective. All the other bottles are going to be meeting the customer requirement. So if such low is going to be your process rejection, then you can imagine how good it will be, because again, because of this very low defect rate, then your productivity is going to be very less. Your inspection cost is going to be very less. Then your customer is going to be very happy. And since your process is very simple, then maybe the cost is going to be very less and you are going to get a lot of profit. So all those benefits you will be able to get. So by using the Six Sigma methodology, you will be able to reduce the defects. So this actually is a graph which is showing like how the defects or rejections is happening before and after doing the Six Sigma project. So assume that this particular project was done in order to reduce the scrap in a chemical process. So before doing the project, the average scrap was around 21%. And you can see that there is a huge variation between 15 to 25. Right? The maximum rejection was 25% and the minimum rejection was 15%. And the average was somewhere around 21%. But after the Six Sigma project was done and the root causes were identified, and then the proper corrective actions were taken, then you found that there is a drastic reduction in the scrap rate from 21% to around 8%. So you can see that there is not only a drastic reduction in the scrap, but you can also see the variations in the output. So that also has come down. So from initial 15 to 25%, Now the variability is now reduced only to 6 to 10%, and the average is around 8%. So the Six Sigma methodology helps you to make a substantial improvement in the metric, whatever you're taking for improvement. At the same time, it also helps you to reduce the variation in the process. Okay. So before going into what is the definition of Six Sigma, let us now try to understand more about the variation. So as I was telling you, the Six Sigma methodology helps you to reduce the defects by reducing the variations in the output, by reducing the variations in the inputs and process conditions. So whenever we are trying to understand what are the reasons for this type of variations in the process, then we can see there are two different types of variations are there. The one is a common cause variation and other is a special cause variation. So again, I'll just give you some example in order to explain what is the common cause and what is the special cause by giving an example. So assume that you are now commuting from your office to home. So the distance is around 30 kilometers. So your house is around 30 kilometers away from the house. So whenever you are commuting from office to house, then again, if you take what is the travel time you are taking, again, you are not getting a single value. So you are getting some minimum and maximum value. So the minimum time taken for you to cover the distance of 30 kilometers, so that is around 30 minutes. So maybe sometimes whenever you are going very early in the morning, or whenever you are returning late from the office to home, then you find that the time taken is very less. So that is around 30 minutes. But again, on some days, whenever you are traveling in the peak traffic, or whenever the road conditions is not right, maybe on that case, you may be getting around 90 minutes. So the average may be 60 minutes. So that means even though on an average, you take around 60 minutes for you to cover the entire distance. So it is not that every day you are going to take exactly 60 minutes for you to cover the distance. So depending upon the various conditions, again, it may be lesser or more. So again, whenever you are trying to understand what are the possible reasons which are contributing to this difference in the travel time, then you find that there are two types of causes you will be able to clearly identify. The first one is the common cause variation. So these common cause variations are always present in the process. Common cause variations are always present in the process. For example, whenever you are commuting from your office to home, then you find that there are the number of traffic signals on the way, number of traffic signals, the waiting time at the traffic signal, then the road conditions, weather conditions. So these are all some of the causes which are always present in the process, and then because of this, you will be able to, you are seeing that some variations are there. So these type of causes which are always present in the process, we call them as a common cause variation. But again, whenever you are analyzing the causes, again, you may be finding the different type of causes, what we call it as a special cause variation. The special cause variation, we can also call that as a assignable cause variation. So when I say assignable cause variation, so that means that are rarely present in the process. So that means they are not present always in the process, but that happens only during some time, sometimes in a day or in some days in a week or something like that. So these are all not going to be always present in the process. So this will be like present for some time and may not be present for all the times, right? So we call that as ascertainable causes. So again, some of the examples for the ascertainable causes or the special causes is the any accident. Suppose on a particular day when you are coming from office to home, there was a major accident. So because of that major accident, the traffic was held up for almost for more than 3 hours. And on that day, it took around 4 hours for you to complete the entire distance. On some other day, maybe there was a political procession. So because of the political procession, then the traffic was diverted through some devious route. And on that day, it took around 5 hours for you to complete the distance. Again, some variation is there. Maybe on some other day, there were some heavy rains were there. So because of the heavy rains, then you had to take some shelter in the middle in a building. So again, on that day, it took around 6 hours for you to travel the distance. So again, you can see that there is a lot of variation in there. But these type of incidents like accident or political procession or heavy rain, so this do not happen on a everyday basis. So this happen maybe very rarely. So even though they have a lot of effect on those days when these problems are there, but in an overall variation for the entire year, then the contribution of the special causes are not going to be very great, right? So the Six Sigma methodology helps you to reduce the defects by reducing the variations due to the common causes. So that is very important. So Six Sigma helps in reducing the chronic problems. When I say chronic problem, that means a problem which is existing for quite a longer period of time. And we were unable to solve those problems before because we were not able to understand what are the root causes of the problems, right? So Six Sigma helps in reducing the chronic problems due to the common cause variation by using the advanced statistical tool. So again, in order to give you some examples in your real work life for the examples of the common cause and special causes, then for the common causes, maybe the vibrations in the machines. So the vibration machine will always be present in all. You can only reduce the vibration. You cannot totally eliminate the vibration in the machine. Then the batch to batch variation in raw material. So again, this is always there in the process. No two batches are having the same material properties. Then skill levels of the people. So two persons, maybe they would have some identical years of experience in the company, but you cannot say that their productivity or quality levels is going to be same. So that may be different, right? So these type of causes, which are always present in the process and creating the variation, these are examples of the common causes: vibration in the machine, batch to batch variation, raw material, and skill levels of the people. And again, if you look for the examples of special cause variation, then the low voltage. So even the voltage fluctuations can also be an example of common cause variation. Because again, the voltage is not stable. So voltage fluctuation always there in the process. So we call that as a special common cause variation. Whereas low voltage, power failure, machine breakdown, then unskilled manpower. So these are all some of the examples for special causes, which are all not always present in the process. So whenever these problems are there, then on those days, a lot of impact is going to be there. But these problems are not going to be happening everyday basis, right? So they are going to be happening on a sporadic basis. So again, in order to still further understand the difference between the common cause and special causes, then you can see the picture on the right-hand side. So you can see that the customer is getting some defective X, which are identified in the red color. And again, he wants to know what is the root cause of the problem. So he traces to the trace. He finds that all the 3 trays are having some defective X. All the 3 chutes are having the defective X. That means all the 3 hens are laid the defective egg. So he is unable to find out what is the exact root cause for the defective egg, and then he is unable to solve the problem. But for example, on another day, again, he is having the repetitive X. He wants to trace it to the tray. Then he finds that the middle tray is having the defective X. That means the middle chute is having the defective X. So that means the middle hen is laying the defective X. So if he removes the middle hen and replaces with the other new hen, then his problem can be solved. So that is an example of special causes, right? So common causes are always present in the process. So we can never identify what are the reasons for the problem. It is very difficult to identify the reasons for the problem. Whereas special causes, they happen sporadically in the process, and we will be able to immediately say that this is the exact reason for the problem. We call it as a special cause variation. And the Six Sigma methodology helps you to reduce the defect by reducing the variation due to the common causes. Okay. Now let me try to explain you what is Six Sigma. So Six Sigma is a data-driven, structured, statistical methodology to achieve the DPMO, that is the defense per million opportunity of 3.4. So it's a data-driven approach. So that means whenever you are doing a Six Sigma project, then you will have to collect a lot of accurate data from the process. And this accurate data, you will have to analyze by using the lot of advanced statistical tools, right? So it is a data-driven approach. And then it is a structured methodology. So whenever I say that it is a structured methodology, there are two ways we can just have that it is having a structure. The first one is it is following a structured methodology for problem solving, which is called as a DMAIC methodology. So when I say DMAIC, then it is define, measure, analyze, and improve and control. So these are the 5 phases of the Six Sigma project. So whenever we have a problem to solve, first we define what is the problem we are having. So what is the extent of the current problem? Then during the measure phase, we collect a lot of accurate data from the process. Then during the analyze phase, we analyze the critical root causes of the problem by using the statistical tools. Then during the improve phase, we are going to make the improvement. And then control phase, we are going to put in some control mechanism in place so that we will be able to sustain the improvement. So any Six Sigma project taken up has to necessarily follow these 5 phases. So it is not that you can skip any projects on your own. That is not possible. You have to, any process, Six Sigma project has to necessarily pass through each phase. And each phase will take a minimum of around 4 to 6 weeks for completion. So a full-fledged Six Sigma project can take around 5 months to 7 months for completion. So if your managing director says that the yield in your process now has suddenly reduced from 95% to 80%, and he wants you to take up a Six Sigma project and improve the yield from 80 to 95% within 1 month. In that case, again, it is not possible through the Six Sigma methodology, because whenever you are doing a Six Sigma project, then you will have to follow a structured methodology for problem solving, and you cannot just like that do the project. So again, it is going to take a lot of time, right? It will take around 5 to 7 months for you to complete the project. So that is one of the structured way of problem solving. We call that a DMAIC methodology. The other type of structure what we have in the Six Sigma methodology is a Six Sigma organization structure. So that means you know how organization structure is very important for any company, right? So in any company, we have the managing director, then all the senior vice presidents and general managers. So they just report to the managing director. Then all the senior managers and managers, they report to the senior vice presidents and general managers. Then all the engineers and supervisors, they report to the managers, and all the workmen, they report to the supervisors. So there is a structured organization structure is there. So whenever there is any problem to anyone who is working in the organization, then they will know immediately to whom they should go so that the problem can be solved. For example, if a workman, he finds that his salary has not been calculated correctly, his attendance has not been calculated correctly, then he knows that he has to go to the HR executive and then present the problem. Whenever a production engineer has a machine problem, the machine has suddenly broken down, then he knows that he has to go to the maintenance manager so that his problem can be solved, right? So that is any company where you want to implement Six Sigma. So a parallel Six Sigma organization structure is going to be in place so that anybody who is taking up a Six Sigma project, whenever they face any problem, then they will know exactly to whom they should go so that the problem can be solved. So it's a data-driven structure, statistical methodology for problem solving. And again, as I told you, if you are going to, your process is running at a Six Sigma level, then you are going to produce only 3 defects per million opportunities. So assuming that the aircraft landing is a process, and in a period of 3 months across the globe, 1 million landings are going to happen. Then out of this 1 million aircraft landing, only 3 landings are going to be defective. And if you are producing some plastic bottles, then you are producing 1 million bottles on a day. Then out of these 1 million bottles, only 3 bottles are going to be defective. So such low is going to be the defect rate if your process is running at a Six Sigma level, so that your productivity is going to be very high, your quality is going to be very high, your percentage on-time delivery is going to be very good. So your customer satisfaction is going to be great. Your profitability is going to be very high. So everybody is going to be happy. So that is the reason why many companies, they want to implement Six Sigma in their organization. So this Six Sigma methodology was first implemented in Motorola. So Motorola was actually a US-based company, and they were into the electronic business during the 1970s and 1980s. And they were facing a lot of competition from the Japanese companies, maybe like Toyota, like Sony and Mitsubishi and all. So then, because those Japanese electronic devices were very cheap and their quality was also good. So the real efforts for coming out with the methodology like the Six Sigma was started in the year 1985 when Bob Gavin, the CEO of Motorola, so when he was addressing his senior management people, then he called them all and then he told them that the quality of the products and services at Motorola has gone so bad that it has started stinking, and we need to do something about that. And then he put 2 of his best quality persons, that is Bill Smith and Michael Harry. So he put 2 of his best people, Bill Smith and Michael Harry, who are the best quality person. And then he gave them some 2 years time. And he gave the target to them that within 2 years, they will have to come out with a methodology so that the quality can be improved 10 times. So quality improvement 10 times. So these 2 people, Bill Smith and Michael Harry, then they worked for 2 years from 1985 to 1987. And they came out with this Six Sigma methodology in the year 1987. And this was first rolled out in Motorola in 1987. So see the success of this methodology in Motorola, then it was implemented in other companies like the Allied Signals and General Electricals. And then subsequently to other manufacturing and service related organizations. So if you think that by implementing Six Sigma, some new inventions were made, some new tools or new concepts are developed. So it is nothing like that. It was only the consolidation of the existing tools and concepts. Because if you see that all the concept of the control charts, which is one of the main important tool you are going to learn in the Six Sigma methodology. So this control charts was in existence even from 1920s. Then some of the statistical tools like the design of experiment. So that was available even from the 1940s. And some of the statistical tools like hypothesis testing. So these were available. These were already existing even during the late 1900s, right? So that means there were no new inventions in terms of the concepts or tools were developed because of the Six Sigma methodology. It was only the consolidation of the existing tools and concepts. So these two people, Bill Smith and Michael Harry, they did a lot of research with the existing quality tools and quality concepts. And then they just found like what are the tools and concepts that can be used in general for problem solving. And then they nicely packed those concepts and tools in the DMAIC methodology, right? So what tools and concepts should be used in the define phase? Then what tools and concepts should be used in the measure phase? So like that, they will just packed it nicely in the DMAIC methodology, and then they were able to get some fantastic results that resulted in a huge cost saving for the companies, right? So no new inventions were made as a result of the Six Sigma methodology. It was only the consolidation of the existing tools and concepts. So we can say that Six Sigma is a toolkit box for solving process problem. So you know that whenever you have any problem, maybe electrical problem, then you know that you just make a phone call to the electrician. So when the electrician comes, does he come empty-handed? No, he comes with a kit box, tools box. So in the tools box, he is going to have a lot of tools for analyzing the problem. And again, in the same tools box, he is going to have some tools which can be used for solving the problems. For example, on a particular day, you found that one of the fan in your house was not running. So you just made a phone call to the electrician and told him that the fan is not running. So again, he came to your house with a tools box. Then as soon as he came to your house, he just opened his tools box and then he picked up the tester from the tools box. And then he went to the switchboard, which is having the fan switch. And then he tested whether the electricity was coming to the fan switch. And if the electricity is coming to the fan switch, but if the fan is not running, then he will analyze that the problem is somewhere between the fan switch and the fan. And then he will again analyze more in that area. If the electricity is not at all coming to the fan switch, then he will analyze that the problem is somewhere between the main panel board and the fan switch. And then he will analyze more in that particular area. So just like how electrician or a plumber or a carpenter is having the tools for analyzing and solving the problem. So similarly, as a process expert, using with the knowledge of the Six Sigma methodology, then you are also going to be exposed to a lot of tools and concepts. So you are going to learn more than 100 different tools, which can be broadly categorized under 4 categories. That is the quality tools, lean tools, then statistical tools, and creative problem solving tools. So you are going to learn about more than 100 tools, which can be broadly categorized into these 4 categories. And then once you get exposed to all these tools, so whenever you have any process problem, then using this any of these tools, then you will be able to analyze what is the problem. And again, using any of these tools, then you will be able to solve the problem. So the Six Sigma methodology is nothing but the toolkit box for solving process problem. So by getting the exposure to all the different tools you are going to learn, you will be able to analyze and solve the process problems. Then there are 2 major driving forces for Six Sigma. There is the customer satisfaction and financial benefit. So again, any Six Sigma project starts by listening to the voice of customer. So try to talk to the customer, try to understand what is the problem they are having in our products or services. So whether there is a problem in the quality or whether there is a problem in the price, or whether there is a problem in the delivery, or whether there is a problem in the services, right? So try to understand what is the problem and then try to solve and improve the customer satisfaction. Then that is one of the customer satisfaction in one of the main driving force for Six Sigma. And since Six Sigma is going to be a bit a complex problem solving methodology, then you will have to ensure that the projects will result in huge financial benefits. So you can see that the initial companies like Motorola or Allied Signals and General Electrical, so they have declared billions and billions of dollars of savings because of the Six Sigma methodology implemented in their companies. Okay. Now we will just have a quick look at what is going to be the defect rate whenever the process is running at the different Six Sigma level. So when a process is running at a Six Sigma level, then I was telling you earlier, then the defect rate is going to be very, very low, equally 3 defects per billion opportunities. And your process can be called as a world-class process, right? If a process is running at a 5 Sigma level, then you can say that the defects per million is around 230. But normally your processes will be running from 3 Sigma to 4 Sigma level. So you can find that your defect rate may be a minimum of around 6,200 DPMO, that is around 0.62%. And sometimes it may be as high as 67,000, that is 6.7%. So your process may be having the defects ranging from 0.6 to 6.7%, and we call that as the industry average. And sometimes some new companies may be running at a very low Sigma level. That means that 1 Sigma, 2 Sigma. So in that case, the defect levels are going to be more. So around, if it is a 2 Sigma, that is going to be around 31%. And if it's going to be 1 Sigma, then the defect rate is going to be 70%. So we can call that in those cases, we will call that they are not competitive. So these type of companies, they may be shut down very quickly because they will not be able to survive the competition. Most of our processes will be running from 3 to 4 Sigma level. And if the process is running from 3 Sigma to 4 Sigma, then the average rejections what you are going to get, or you are going to lose approximately around 20% of your revenue, 20% of sales, you will be losing because of the quality, right? But if your process is running at a 6 Sigma level, then it is going to be less than 10%. So that means only around 5% of the sales you are going to lose because of the bad quality of the product. So that means you'll be able to save around 15 to 20% of your profits by implementing Six Sigma in your organization. So huge cost savings will be there. And that is one of the major reasons why companies, they implement Six Sigma in their organization. Okay. Okay, now again, this slide will compare the two processes. A process which is running at a 99% yield. That is, only 1% is going to be rejection. So many of my participants, I just ask them what is their scrap rate. Then they proudly say that their yield is around 99%. So only 1% of their output is going to be rejected. And when I ask them, is it possible for you to improve your yield from 99% to maybe 99.9, 99.4%, the increase of 0.4%, then they will immediately come and tell me that running at 99% itself is going to be a very huge task. So that is going to be a very proud moment. So increasing by 0.4% to 99.4% is impossible. Immediately their mind will block. But again, if you just see, like, is it possible for you to improve the yield? Currently, your rejection is around 10,000 ppm, right? When I say ppm, it is parts per million. So currently your rejection is around 10,000 ppm. So can you now reduce it to 6,000 ppm? Then immediately they will think and say, okay, currently my defect rate is very high at 10,000 ppm because 10,000 is a very high number. So reducing from 10,000 to 6,000, maybe I can try. Even though reducing the scrap from 1% to 0.4%, 0.6% is the same as reducing the scrap from 10,000 ppm to 6,000 ppm. So that means since the numbers are big, if you measure in ppm, so whenever you are wanting to implement Six Sigma in your organization, so now you'll have to start measuring where rejections and scrap rate, not in terms of percentage, but in terms of the ppm, that is the parts per million. So once you start measuring the rejections in parts per million, then you are going to get a very big number. So that will really open up your mind, and then say that reducing the defects to very low level, like maybe 10 ppm or 20 ppm or 200 ppm is really achievable, right? So again, some of the examples are given here. If your process is running at a 99% yield, that means only 1% of your process is rejected. Then across the globe, around 20,000 letters are not going to reach the final destination, right? If your process is going to be a 99% yield process. But if your process is going to be a Six Sigma process, only 7 mails are going to be not reaching the destination. So that means your defect rate is going to be reduced 3,000 times. So 3,000 times the defect rate is going to be reduced if we move from 99% accurate process to a Six Sigma process. So your defect rate is going to be reduced 3,000 times if you are going to improve your process capability from 1% defect rate to the Six Sigma level, right? So that is the reason why most of the companies, they prefer to go for Six Sigma. Okay, are there any doubts or any clarifications in whatever you have covered so far?
No.
So
No, sir.
yeah, so basically two fundamental approach principles. That is a process approach, which says control the inputs, control the process conditions, output will always be consistent. And second thing is about the variability. Variability is inevitable in any process, and the Six Sigma methodology helps you to reduce the defects by reducing the variations in the output, by reducing the variations in the input and process condition. Then we learned about the two types of variations, common cause and special causes. Then we learned about a bit of what is Six Sigma. So these are structured problem solving method using a lot of data and using a lot of statistical tools. And we compared the two processes with having a 1%, 99% yield process with the Six Sigma process, and found that a Six Sigma process produces 3,000 times lesser defect when compared to a 99% yield process. Okay. Now let us learn what are the different activities we do in the DMAIC methodology, right? So the DMAIC methodology is used to improve the existing process and the existing product. So if your process is running for more than 1 year and you are finding that the variability is the issue, then you can use the DMAIC methodology for solving that particular problem. So for example, now assume that you are currently running your ERW pipes production process, and you are finding that your last 1 year yield data, if you are going to take. So can you tell me what is the yield data for what is your average yield?
Average yield maybe 88%.
88%.
Yes, sir.
So what is the best you got so far? Best result in a month?
I think 89% somewhere.
No, 88% is the average or 68%?
Yes.
88% is the average. What is the best? What is the best result you got?
Best result of 1 year maybe I think is 85% or something, sir. Exactly, I don't know.
Okay. What is the,
Because actually we are not calculating only for API, we are only calculating yield.
Mhm,
Others, for other pipes, we are not calculating.
mhm. Okay.
Actually,
Yeah.
so from last, actually, we have do some analysis and change the RM, means raw material.
Mm.
After that, we are getting some improvement in yield.
Okay. So many times what happens is even though the average may be 88%, so sometimes you may find that that yield is maybe as low as 80%, but sometimes it may be very good at 95%, right? So always there'll be a variation, right? So
Yes, sir.
maybe the process is running for a longer period, maybe for around more than 1 year. But again, we find that sometimes the process is running very fantastic. So the yield is very good at 95%, but sometimes there's a process running very bad. So again, 80% is the yield. And we do not know what are the root causes for the problem. So in that case, we can use the DMAIC methodology. So the DMAIC methodology is used for improving the existing process and the existing product by reducing the variations in the process, right? So the improvement takes place by reducing the variability in the process. So let us now try to understand what are the different activities we do in the different phases: define, measure, analyze, improve, and control. So in the define phase, we start with listening to the voice of customer. So listen to VOC, the voice of customer. So you can directly talk to the customer, or you can talk to your sales people, or you can talk to your quality people, and then try to understand what is the problem the customer is facing in any of your process, in your products or service. So whether quality is a problem, or price is a problem, or delivery is a problem, or services is a problem. So try to talk to the customer directly, or try to get the feedback from your customer service or the sales people or the quality people, right? So listen to the voice of customer and then understand their pain points. So that means you'll have to identify critical to X factor, right? What is causing more pain to them? Whether the quality is causing more pain to them, or your delivery is a problem for them, or the price is a problem for them, right? Try to identify which is very critical to them, whether the quality or delivery or price or the services. So identify the critical to X factor and then link it to a measurable metric. So for example, when you talk to the customer, then the customer may be saying that, okay, all the other things are fantastic, but only we are a bit concerned about the delivery. Your delivery is not consistent, so sometimes it is getting delayed. Then you know that when you listen to the voice of customer like that, then you can understand that the pain point is on delivery. The critical to X factor is the critical to delivery. Then link it to a measurable metric. So how you are currently measuring the delivery performance. So we are measuring the delivery performance by measuring the percentage on-time delivery. So we have agreed with the customer that our percentage on-time delivery will be 95%. That means 9 out of 100 deliveries, whatever we are making to the customer. So minimum 95 deliveries will be delivered within the due date, on or before the due date. Only a maximum of 5 deliveries will be made after the after the due date. But again, now you are finding that the customer is saying there's a problem in the critical delivery. He is having a delivery issues. Then now you are trying to compare or analyze the data last 6 months. So what is the delivery performance? So you are measuring the delivery performance in terms of the percentage on time delivery. So now you have to quantify the performance. quantify the problem. Now the customer is saying there's a delivery issue, and you have agreed that the percentage on-time delivery will be 95%. But when you are closely analyzing the current data, you may find that the current status is only 80%, right? So currently your on-time delivery is only 80%, and that is the reason the customer is taking that as a problem, right? So you listen to the voice of customer, then try to understand what is the pain point for the customer, what is critical to expect for him, and then try to link it to a measurable metric, and then quantify the problem. So what is the current status? And then fix up a target. So our target is 95%, whereas the current performance is only 80%. Then there is a huge opportunity for improvement. Then you just try to take up a project, say that I want to improve the percentage on-time delivery from 80% to 95%, right? Then you just write a business case. So when I say business case, why you are taking the project and what are the problems you are going to face if the problem is not going to be solved, and what benefits you are going to get if the problem is going to be solved. So maybe currently, since your on-time delivery is not consistent, maybe 25% of the order goes to your competitor. And if you are going to improve your current delivery performance, then the customer can give you 100% of the order, right? And because of that, you will be able to get some $300,000 as a profit. So you write a business case, right? Why you are taking the project? What are the benefits you are going to organization is going to get? Then you just form a team, appoint a team leader, and then you just define the scope of the project. So whether the project is done for a particular product or a particular customer, or whether it's going to focus on a particular process. So you have to define the scope of the project. So the more and more you narrow down the scope of the project, then the better will be the possibility of successfully completing the project. And then you just prepare the schedule for the project. So what is the date each phase, like a different phase, measure, analyze, improve, and control. So when each phase is going to start and end. So once you define all those, then you just document in a document which is called as a project charter. So a project charter is one of the major deliverable from the defined phase. So where you are starting with listening to the voice of customer, VOC, then link it to a measurable metric, try to understand what is the pain point, then link it to a measurable metric, and then quantify the current problem, fix up the target, define the scope of the project, write the business case, form a team and the team leader, and define the scope of the project, and prepare the schedule for the project, and document everything in a document called the project charter. So these are the major activities we do during the define phase. Then once you have done that, then we move to the measure phase. So in measure phase, we are going to collect a lot of data from the process. So the measure phase. So we'll have to come out with a data collection plan. So what data you are going to collect, when you are going to collect the data, from where you are going to collect the data, who is going to collect the data. So what is going to be the definition of the metric, whatever you are collecting the data. All those has to be clearly defined in the data collection plan. Then you'll have to do an activity which is called as a measurement system analysis. So for example, now you are doing this grinding of rod from 11 millimeter to 10 millimeter, and the customer is willing to accept from 9.5 to 10.5. So what may happen is, like one of the piece sample is measured as 9.4, but its actual dimension is 9.6. So in that case, it is actually a good material, but since you are wrongly measured as 9.4, then you are going to reject it. The other way around, that is also possible. So some other sample may be measured as 9.6, but the actual dimension may be only 9.4. So in that case, you may accept it, but actually that should have been rejected. So since you are not measuring the diameter accurately, so that way that can just have an impact on the measurement of the yield. And if you are going to take up a project to improve the yield, whenever your measurement itself is not correct, then the results are not going to be accurate. So that is the reason you will have to do an activity which is called as a measurement system analysis to ensure that your measurement system, that means you are measuring instruments, the operators, their measuring methods, and any environmental conditions. So everything is under control so that you will be able to get the accurate data. So for ensuring that, you do an activity called as a measurement system analysis. Then you also do process capability analysis. So that means we are going to calculate what is the current process capabilities in terms of sigma level, right? So if your scrap rate is around 6.7%, then you can calculate your current process capability at 3 sigma. And then you just do the process capability studies during the measure phase to know what is the process capability before the improvement is done. And then again, after the improve phase is completed, again, you measure the process capability, and then maybe it is increased to 3.8. Then you can prove that the process has improved from 3 to 3.8. So there is a substantial improvement in the process. So you do a process capability analysis during the measure phase in order to find out what is the percentage of scrap you are getting before the improvement is taking place, right? So these are the three major deliverables of the activities you do during the measure phase. Then during the analyze phase, then you are going to analyze what are the potential causes for the problem. So you start with the fishbone diagram. I think both of you are from quality team, so you would have heard about this fishbone diagram, which is called also called as a cost and effect diagram. So you just start with the fishbone diagram. So you may get around 50 to 70 potential root causes for the problem. Then you just prioritize those root causes by using the various quality tools and the statistical tools. So that at the end of the analyze phase, you are going to get a list of statistically validated critical root causes for the problem. So whenever I say list, it is not that we are going to have a list of some 15 or 20 different critical root causes. We are going to get a list of 3 to 4 maximum, not more than that, right? So at the end of the analyze phase, we are going to find out what are the 3 or 4 critical root causes which are contributing to the problem. So during the improve phase, we are going to take action only on those 3 or 4 critical root causes, right? So that is what we do during the analyze phase. Then during the improve phase, then we just take action. We just develop alternate solution. So now that you know what is the problem, what are the root causes for the problem, now you just develop some alternate solutions to address those critical root causes. Then select the best solution. Select the best solution out of all those different alternatives. Then run pilots. You cannot make the changes in the regular production. So you just run some pilot scale. That means in a very small scale. Then estimate the savings and the improvement. Based on your pilot, try to analyze what are the improvements you are able to make, right? And if you are able to meet the targets, then you do a risk analysis. So for example, you may just take up a project to improve your yield in a chemical process from 80 to 95%. So currently you are having output of 300 kgs per shift. But after the Six Sigma project has been completed, maybe your yield has now improved from 80 to 95%, but your output per hour has now gone down from 300 kgs to 100 kgs. So in that case, whatever the advantages you are going to get by the improved yield may be more than offset by the reduction in the output per day. And then that is the project may not be a successful project. So in order to ensure that, we'll have to do a risk analysis. So you are now doing a project to improve the yield. So you are now recommended some actions. So that by implementing the recommended action, are there going to be any negative impact? So you have to proactively analyze those possible risks, and then we'll have to take some proactive actions so that these changes can be implemented without any major side effects, right? Major side effects. So that is the purpose of doing the risk analysis. And then the improve phase will end by preparing a plan for full-scale implementation. So that means at the end of the analyze phase, at the end of the improve phase, it is not necessary that the improvements would have been achieved in the full scale, but at least the improvements would have been achieved at the pilot scale, and you have a plan in place for implementing to the full scale production. Then during the control phase, you are going to put in some control mechanism in place so that you are going to get sustain the improvement. So many times what happens is, even in our current day-to-day life, it is not that we are not making any improvements. Definitely, we are taking some efforts in order to make the improvement. But unfortunately, what happens is we are not analyzing the root causes of the problem. So since we are not analyzing the root causes of the problem, we are not finding the permanent solution for the problem. And again, the same problem may be coming again and again, and we are not able to sustain the improvement. So in order to avoid that, in the Six Sigma project, during the control phase, you will have to put in some lean control mechanism in place. So we are going to learn about some tools like the 5S, standardization, okay. So these are all some of the lean tools that can be used to ensure that we are able to sustain the improvements. Then we are to control the process, the critical inputs and the output by using the control charts. We also call it the SPC, statistical process control. So that means, as I told you, we'll be finding that only some 2 or 3 critical root causes are contributing substantially for the variation in the process. So during the improve phase, then you are going to find out what are the optimum settings of those critical inputs. Then in the control phase, you are going to ensure that these critical inputs, the input or the process conditions, are to be managed in a very narrow range so that you'll be able to get the consistent result. Then we also going to make a document which is called as a control plan. So a control plan is actually a detailed document. So which will tell you like the end-to-end process. So what are the input parameters you are going to check and control? What are the process parameters you are going to control and check and control? And final inspection, what are the different parameters you are going to check and control? So all those things will be documented in the control plan, right? So there's lean controls, statistical process control, and control plan. So this is what you will be learning during the control phase. Then once your project has been completed, and then the cost saving has been measured for almost 1 year, then you can formally close the project by writing the closing report. So the closing report is actually a document, like a project single page document, like a project charter. So again, giving like information on what are the problem you wanted to solve, what are the current performance, what are the target you wanted to achieve, what was the scope of the project. Then during the measure phase, then what type of data you collected from the process. And then during the analyze phase, so what are the critical root causes identified, which are statistically validated. And during the improve phase, what improvement actions were taken. So what are the risk analysis done? Again, what are the sustainable during the control phase? So what type of control mechanisms were put in place to sustain the improvement? So all those will be documented in a 1-page document, which is called as a closing report. So these are the different activities we do in the end-to-end DMAIC methodology, right? Define, measure, analyze, improve, and control. During the define phase, you are defining the problem. During the measure phase, we are collecting the data. During the analyze phase, we are analyzing the data using the statistical tool and find out the list of critical root causes. During the improve phase, we are addressing the critical root causes and improving the process. And during the control phase, we are putting in some control mechanism in place so that we'll be able to sustain the improvement, right? So that is about the DMAIC methodology. Okay. Any doubt or any clarification on this?
No, sir.
Okay. So I have
No,
told
sir, no.
that, yeah. So I told you that the DMAIC methodology is used for improving the existing product and existing process, right? So that's what I clearly told you. DMAIC methodology is used for improving the existing process and existing product. But sometimes what you may find is that you want to improve a new process or a new product. So in that case, how will you make the improvement? So in that case, we use a methodology which is called as a DFSS. It's called as a Design for Six Sigma. There we use the, instead of DMAIC methodology, we are going to use a DMADV methodology, right? Define, measure, analyze, design, and verify. So instead of improve, we have design, and instead of control, we have verify. So let us now try to understand the DMADV approach by looking at an example. So I assume that you are working for a car manufacturing company like the Maruti, and you had one of your new model of the car has been released recently, and your marketing team was projecting that your market share will be 50%.